Hello, this is the lesson for 1-2 in Secondary 1. So what you should have already done is you already should have picked up your packet. You should have completed the warm-up. And that's the first page of your notes, and that will be the same case every day. And so on this warm-up you have 8 problems, and you're going to do the very best you can. Usually your warm-up will remind you of the things that you've learned so that you can do your quiz. And so we're going to go over the warm-up first. Then you'll have your 2-question quiz. And then we'll get started on the rest of the lesson. So I'm going to go over the warm-up now. You should have already done it. Now if there's any problems that you haven't done, or you didn't get to, or you didn't know, or you didn't have the right answer, then fix it. Erase what you have or cross out what you have and write the correct thing down. The warm-up is for you to get your brain ready to remember things. You can make mistakes. It's not going to matter if you make mistakes, but what does matter is that you tried it. So let's go ahead and go to the first problem on the warm-up. This is an order of operations problem. There's grouping symbols, the brackets, and then the parentheses. So the first thing we're going to do is the parentheses. So 4 minus 6 is -2. And then nothing else is going to happen in my first step. A common mistake people make is they'll think that that is -2 to the third and just type it in their calculator. You're not supposed to be using a calculator on this, but what you need to remember is that's -2 times -2 times -2. So 2 times 2 is 4, and times 2 is 8, and a negative times negative is positive, times a negative is negative. So -8 comes from that part of it. Okay, the next thing, bring down the +2, and again, I'm not doing anything else. You don't want to do too many things in one step because that's a really good way to get things mixed up. Trust me, I know these things. Okay, so the next thing we're going to do is we're going to do -8 plus 2, and that's -6. And so -6 divided by 5 is equal to, get this, -6 divided by 5 as a fraction. A lot of times students will panic if they get a fraction or something that doesn't work out just perfectly, but it's okay. A fraction is a legitimate answer. So you're just going to leave it like that. That's my answer. You're not going to change it into a decimal, okay? Leave it as an improper fraction. I like to say that mixed numbers are of the devil, so I don't want to see any -1 1/5 business, okay? None of that. I don't want to see a -1.2 because A, that means that you probably put it in your calculator because not a lot of people at this point know that off the top of their head. And B, I don't want you to do that. Improper fractions, as we go higher and higher in mathematics, we work with improper fractions more and more. You need to be comfortable, so that's one thing we'll be emphasizing this year. Okay, the next problem on the warm-up is 9 minus 3 is on the top of our fraction. It's in parentheses, and so that's going to indicate that it's going to go first. So 9 minus 3 is 6, and it's still in parentheses because we're going to take all of that to the second power. Sometimes parentheses are in a place where they don't really matter, and sometimes they do, as we saw in the last problem. This one, it doesn't matter because 6 times 6, it's going to be the same with or without parentheses. And then divided by 3 times 6. Now 36 divided by 3 times 6 is 18. You may not know that one. Okay, that may be something that you're like, I don't know what that is. So let me show you something. And when I used to teach 7th and 8th grade, I would always show it to students like this. If you've got 36 on top, well, it just came from 6 times 6, didn't it? And on the bottom, you've got 3 times 6. Now, as long as everything's being multiplied, you can say, well, 6 divided by 6 is 1. So what do you have left? You have 6 divided by 3, and that's 2. So that's the answer to this problem. That's what 36 divided by 18 is, 2. Okay, so make sure you've got this written down, and you may have to go back later and go over it to make sure you understand everything, but that's how you would do that. Okay, number 3, 12 minus 10 is 2 plus 3. So I just did this part because you do addition and subtraction from left to right, and subtraction was first there, so we did 12 minus 10. And 2 plus 3 is 5. Okay, the last one for this section is 14 minus 5 times 3 minus 6, so in parentheses. 3 minus 6, so I'm not going to do anything else. This is something that really causes a lot of problems because everybody wants to do the 14 minus 5 first. 14 minus 5 does not come first. It doesn't even come second. What's going to come next after this is you're going to take this number, which is -5, And it might help if you look at that as plus a negative 5. But you're going to take that negative 5 and you're going to multiply it times negative 3. So you're going to have 14 plus 15. Okay, so let's make sure you've got that written down correctly. Now, if you come across a problem, and especially if I'm not here, but if you have a problem with something, you need to write a question mark next to it. Now, even if I am here, then at least you know what your questions are, and so when you have the opportunity, you need to ask me a question. So put a question mark by that if you're not really sure. Okay, 14 plus 15 is 29. And I can do that by saying 10 and 10 is 20, and 4 and 5 is 9. And so 20 plus 9 is 29. And so even though we're saying do this with no calculator, there's a lot of ways to think about it that make this not very hard. Okay, let's go to the next section on the warm-up, and this was solving literal equations. Now, you may not have seen this year, but you have seen it before. And these are just one-step equations, so we're solving for v. So here's v, and I want to get that by itself, so we're going to subtract in from both sides. Now, I know some of you may not have known how to do that, but I'm hoping a lot of you did know how to do that. So this is your answer. That's it. You've solved for v. And so that's all you have to do. Okay, let's go to number 6. This one's solved for w, so here's w. So we're going to get that by itself. So you need to think about, okay, how do I get rid of the k? The k is what's the problem. So it says divided by k, so I'm going to multiply by k over 1. And the reason I do that is because then the k's cancel. So if I do it to one side, I have to do it to the other side. So I'm going to have w is equal to yk. Or you could say ky. It doesn't matter because multiplication is either way. All right, and then last on the warm-up is number 8, and we're going to solve it for y. So we are going to add p to both sides. That gets the y by itself. And so I'm going to have y is equal to z plus p. You could also say p plus z. Again, order doesn't matter with addition or multiplication. Okay, at this point I'm going to give you some directions. And so what you're going to do is you're going to get out your homework from yesterday or last time. You're going to make sure name and class period is on the top in the lines where it goes. You're going to pass those papers to the front and they'll be collected. So you can pause this video while you do that. Okay, now that you've turned in your papers, now what you're going to do is your warm-up, you're going to put that underneath your desk. You are going to receive a short 4 question, I think it's 4 questions today, quiz. Now these quizzes you're going to get every day, they're going to be worth 4 points every single day. So 4 points, and so it might be 2 questions or it might be 4 questions. I think today's is 4 questions, and it's over order of operations, what you were supposed to do from your homework last time. And so in order to get your accuracy points, you're going to do this quiz. And it's pretty much all or nothing, so you need to do the best you can. There are no calculators on it. You're going to go through and do these problems the best you can. When you're done, make sure your name's on it. Put it in the basket that says your appropriate class period, or A day or B day, and then you'll return to your seat and sit quietly for a minute or 2 while everybody finishes. Then we will continue with the lesson. Okay, for today's lesson, we are going to talk about solving 1- and 2-step equations, which you already know how to do 1-step equations for sure, and you have done 2-step equations before as well. But we're going to bring in some other things into it, and it's called justification. So we're going to justify, or we're going to start to learn to prove things or to validate things. So in this first sentence at the top of the paper, it talks about the Utah State standards. You don't really have to worry about that so much. It just tells us which standards we're meeting today or we're working with today. But this paragraph right here, this is where you would use your highlighter to highlight important words or phrases that would help you remember these things. So equations are mathematical sentences that state 2 expressions are equal. So you're going to have an expression equals another expression. When solving equations, we are undoing what is happening to the unknown variable. So you're kind of like unwrapping a present. In order to solve equations in algebra, you must perform operations that maintain equality on both sides. You can't do something that's going to make it unequal, because then your equation is no longer true. And so we have certain properties or rules that we follow. And so that's what we're going to be talking about today. These rules allow us to balance, manipulate, and solve equations. So on the table below, here's a summary of the rules we're going to talk about today. Okay, the first property, it says addition property of equality, and we are going to abbreviate that as APOE. So you can write that down. Now in symbols, what the addition property of equality it says if A is equal to B, then you can add the same thing to both sides. As long as you add it to both sides, we're fine. So A plus C is equal to B plus C. So when you have an equation that says, x plus 2 equals 3, if I decided, hold on, I don't want to do that. I'm going to say x minus 2. And then so I'm going to add 2 to both sides. As long as I'm adding 2 to both sides, that's not a problem. So you see, you already used that property. This isn't new. So in words, adding to the same number to both sides of an equation does not change the equality. Okay, the next one is called subtraction property of equality. We're going to abbreviate that as SPOE. And that says the same thing except for when we subtract the same thing from both sides. So that would be like if I had x plus 2 equals 3, I would subtract 2 from both sides. And that's meeting the subtraction property. And so that's what that says. So it just says subtracting the same number from both sides of an equation does not change the equality. Okay, the next one is called the multiplication property of equality. You can probably guess what we're going to call that, MPOE. And that's just so you don't have to write the whole thing out. And that just says if you multiply both sides by the same thing, then it's not going to do anything harmful to your equation. So if you have like 1/3 x equals 2, then I could multiply that by 3 over 1, and nothing bad's going to happen. It's still going to be equal. And so just like we did in the warm-up, you can do that to solve an equation. So you just have to make sure you multiply both sides by the same number. Okay, and then the last property that we're talking about right here is division property of equality, so DPOE. And that just says if you divide both sides by the same number. So for example there, if you had 3x equals 6, and you wanted to solve that, you would divide by 3 and divide by 3. And so as long as you're dividing both sides by the same thing, that's no problem. And that's how we solve equations. So the next thing that we're going to do is we're going to talk about something that is new to you, and that's called set notation. Set notation is just simply a way that we write solutions to equations, and we're going to be doing this throughout the year, and then you'll be doing it in years to come. So set notation, if we see something like this, that is set notation. So what it says, let me break it down for you. You've got braces, which are these curly Q things. It says x, because that's going to be my variable. Then it's got this vertical line, and in words that means such that. So that means x such that x is equal to 5. And so you're going to write your equation. Instead of just writing x equals 5, you're just going to write x such that x equals 5 in set notation. So in here we're telling you why it matters. A set is a group of distinct objects. And so in this example, the set only has the number 5, and so it's very simple. Set notation is really useful once we start getting multiple solutions to equations, which we don't have now, but we're going to practice while it's easy. Okay, so let's do some problems where we solve using our justification, our properties that we just talked about, those, and we're going to also write our answers in set notation. So let's go to number 1. So you'll need to fill in where I've got the bright yellow. That means that your paper is missing those numbers, and so you're going to need to write that in there. Okay, so we've got the equation m minus 8 equals negative 5, and why is that? Well, because it's given to me, that's why. We didn't do anything to get that, it was just given to me that way. Now I have to solve this. So my step, how do we get from here to here? What do you do to get there? And so if you think to yourself, okay, to solve this, I have to get the m by itself, so I'm going to add 8 to both sides. Now, I'm hoping that everybody knows how to do that, because that was something you learned in 7th grade, so hopefully that part of it isn't new. But when you add 8 to both sides, what did you just do? You just added to both sides. So that tells me that the addition property of equality is my justification for getting that answer right there. And so that's all we're doing. We're just setting this up in a way that we're justifying what we're doing. This really gets us ready for a lot of things that come up later with our geometry. The last box that we're going to do is we're going to write this in set notation. So we're going to write the braces, m is our variable this time. So we're going to write m such that m equals 3. And then you close your braces, and that's it. Okay, let's go to number 2. Okay, this equation, negative 35 equals 7x. So you're going to need to write that part on your paper because you don't have that on your paper. And then I'm telling you that the answer is x equals negative 5. So your job is to figure out how do we get that? What's the justification? So look at the equation. If I was to solve for x, how would I get the x by itself? So it says 7 times x. The opposite of multiply is to divide. So if I divide both sides by 7, then what did I just do? I just divided both sides by 7. So the reason that I get x equals negative 5 is the division property of equality. So you need to be writing all of this that we're doing. You need to be writing the justification. And then the last thing is you're going to write the set notation. So can you write the set notation? Braces, and then what's going to go inside? What's our variable? That comes first, such that. And then x equals negative 5. Okay, I'm only allowed so much time on each video, so we're going to stop this video and start the next one to continue the lesson.